Today we're going to look at absolute value, which is a function in mathematics that has its own definition, and it comes into when we're solving equations and also for graphing. So absolute value is something that's defined for a real number. The absolute value of a real number is the distance from that number to 0 on the number line. So for example, if there's a number line and there's 0, you might have a number that is plus 5. Well, that is 5 units away from 0. Or you might have negative 5, which is also 5 units away from 0. Remember, when you talk about distance, you don't have negatives. Distance is always a positive thing. So when we talk about the absolute value, we're talking about the positive distance from that number to 0. For example, here you have 4. What this is saying in terms of a number line is it's saying here's 0 and here's 4. And it's asking what is the distance from 0 to 4. It's 4 units. Over here for this one, negative 9.2, you have 0 and you have negative 9.2. And what's the distance between here and here? The distance is also 9.2 units. Even though you're landing at the negative 9.2, a distance traveled is only 9.2. So we say that it's 9.2. So what you need to know is that whether you have a positive or whether you have a negative, your answer should always come out of an absolute value as a positive value. Now, when you have two numbers inside your absolute value, it's important that you simplify insides first. So think about PEMDAS. PEMDAS says that you always do parentheses, exponents, multiplication, division, etc., etc., etc. You want to think about the absolute value kind of like your parentheses. You do what's inside of them before you do anything else. So inside of the absolute value, we have 3 minus 8, which is a negative 5. The distance from 0 to negative 5 on the number line is positive 5. So again, the answer comes out positive, but not out here, but after you simplified. Let's look at an example where you're asked to evaluate. Remember, evaluate means to plug in and simplify. To plug in and to simplify. So as we're looking at this example, we will say absolute value of 3 plus 2 times absolute value of 3 plus 3 minus absolute value of 3 minus 1 absolute value. Inside the absolute values first. Well, this one, there's nothing to do, so we'll just say, what is the absolute value of 3? It's 3. This one here, plus 2 times the absolute value of 6. And then minus, this is the absolute value of 3 minus 1 is 2. So continuing our simplifying over here, we have a 3. 6 will come out as a positive 6, so 2 times 6 is 12. And then 2 comes out as a negative 2. This negative is still there because it's outside the absolute value. So it's negative 2. So 3 plus 12 is 15 minus 2, which is 13. As your final answer. Alright, so now that we've seen a little bit about what absolute value is and what that means, we're going to talk about when we're solving. So since an absolute value is a distance and it could be positive or negative, so think about if I said the absolute value of x equals 5. Well, remember, on a number line, that means that from 0, I might be talking about going to positive 5, because that is positive 5 units away from 0. Or I might be talking about going to negative 5, because that also is 5 units distance-wise away from 0. It could be either one. So this top example here could be written as maybe the inside is really a 5 going out in the positive direction, or maybe x is really a negative 5 inside of that absolute value. Because if I take the absolute value of positive 5, or if I take the absolute value of negative 5, either way, I will still get 5. So anytime, here's your definition, anytime you have absolute value of something equals a number, you want to say that it can equal either the positive or the negative of that number. So you say x minus 3, the insides, might equal positive 6, or the insides, x minus 3, might equal negative 6. And then the absolute values have disappeared. They're not there once you say that it could be the plus or the minus. Let me fix this one up here. Okay, so that's what you should always see for your definition. You take this side here, you turn it into a plus, and you turn it into a minus. It makes the absolute value go away. So when we're solving absolute value equations, the first thing you need to make sure is that you do isolate the absolute value. We'll talk about that. So isolate the absolute value. Then 2, rewrite it, just like we saw above, with a plus or a minus on the outside. And then you solve for x. And then make sure that you always check your answers. This will become especially important for our next lesson. So check answers. All right, so first example here. The absolute value is isolated, meaning there is nothing added or subtracted and nothing multiplied or divided to the absolute value. So we will say 15 minus 3x equals positive 6, or, and then over here, 15 minus 3x equals negative 6. All right, had to change the document a little bit. But again, notice you have your 15 minus 3x is the positive, or 15 minus 3x is the negative. Should be both of those. So then you solve each one individually. So for this one over here, I want to isolate the x, so I'm going to subtract 15 from both sides. So negative 3x equals negative 9. Divide by negative 3. So x equals positive 3. Or, on this side, subtract 15 from both sides. We get negative 3x equals negative 21. Divide by negative 3. So x equals 7. So x could be either one of these. Now we check, and using our absolute values here, check if we have 15 minus 3 times 3, does that equal 6? So this would be 15 minus 9. And 15 minus 9 would be positive 6. Absolute value of a positive number is still positive distance, so yes, 6 equals 6. Check. For your next check over here, save some space. We're going to try absolute value of 15 minus 3 times 7. Absolute value, does that equal 6? So absolute value 15 minus 21. And 15 minus 21 is negative 6. So absolute value of a negative number is a positive. So yes, 6 equals 6. So these ones both work. All right, let's look at another example. This one, we have to isolate the absolute value before we can start solving, meaning there's a 2 connected by multiplication. We're going to have to divide both sides by 2, and that only cancels the outer 2 right here. So now we have absolute value of 4x minus 6 equals 2. Then we split it into the 2 ways. So we say 4x minus 6 equals positive 2, or 4x minus 6 equals negative 2. Again, always make sure that you do positive and negative on that outside number there. So we add 6 to both sides. We get 4x equals 8. Divide both sides by 4. We'll have x equals 2. Or add 6. 4x equals 4. Divide by 4. X equals 1. Check over here on the side. So 2 absolute value of 4 times 2 minus 6 equals 4. 2 times 8 minus 6 equals 4. 2 times 8 minus 6 is just 2. Absolute value of 2 is just 2, so 2 times 2 is 4. Check. Next one. 2 absolute value 4 times 1 minus 6 equals 4. So 2 times 4 minus a 6 is a negative 2 equals 4. But the absolute value says the distance of negative 2 to 0 is positive 2 equals 4. Check. So both answers work. Here's another example where we're going to have to isolate the absolute value before we can solve. So we need to move the 5 out of the way. So subtract 5 from both sides, meaning we have negative 2 absolute value of x plus 9 equals negative 10. Divide both sides by a negative 2, cancels only the outside there, which means that we have absolute value of x plus 9 equals positive 5. Split it into your two ways. So x plus 9 equals positive 5. X plus 9 equals negative 5. Again, two values. Subtract 9. So x equals negative 4, or subtract 9 again. X equals negative 14. Check. So 5 minus 2, absolute value negative 4 plus 9, absolute value equals negative 5. 5 minus 2, negative 4 plus 9 is a positive 5. So this becomes 5 minus 10, which, yes, that equals negative 5. Check, so this one works. Next one, 5 minus 2, absolute value negative 14 plus 9 equals negative 5. Negative 14 plus 9 is negative 5. But again, the absolute value is going to make this a positive 5. So we'll say it's still 5 minus 10 equals negative 5, which, yes, that will also work. So there you are. So again, just to recap our absolute value is always the distance from any number to 0. So you should already have this in your notes, the distance from any number to 0, and distance is always positive. So whenever you have an absolute value equation like you have here, you always take this outer part and you make positive and you make negative and you solve both pieces.